All right, so today we are in Algebra Chapter 8, and these notes will actually be for both sections 2 and 3. We're talking about multiplying polynomials, so make sure you have that in your table of contents. And then flip over to page 83. So, like I said, today we are multiplying polynomials. All right, so really what we're doing today is just some examples, and I'm going to show you basically 3 different ways to kind of look at this. If I have something like this, if I have negative 2/3 n squared, and then in parentheses, I have negative 9n squared plus 3n plus 6. Well, just like if I had a number outside the parentheses, all I'm going to do is distribute. So I'm going to go negative 2/3 n squared times negative 9n squared. Now the numbers are just numbers. You just multiply them, use a calculator, and you will get 6. N squared times n squared is n to the 4th. Now I do negative 2/3 n squared times 3n. Once again, the numbers, you just use a calculator and you'll get negative 2. N squared times n is n to the 3rd. And then negative 2/3 n squared times 6. The numbers you just throw in your calculator to get negative 4. And then there's no other n's, so it's just going to be n squared. And there you are, you're done. So anytime you're doing, this is a monomial times a trinomial, but anytime you're multiplying with polynomials, you can definitely look at it as, hey, I'm just distributing. Now, if there is in particular a binomial, which is 2 terms, times a binomial. We're going to be doing a lot of these this year. And so I'm going to teach you this simply because you'll hear it in the future. You need to know what it is. So it's called the FOIL method. And so the FOIL stands for first, outer, inner, and last. And usually, although not always, you're going to take the outer and inner terms and add them. Okay, so you're like writing this down going, I have no idea what you're talking about. Okay, so let me give you an example. So if I have this x plus 4 times x minus 2. So 2 terms, so it's a binomial times a binomial. Now, the first term in each set of parentheses, the x and the x, those are the first. So the first times the first, x times x is x squared. Now, the outer 2, so I have 4 things here. So these 2 that are on the outside most, those are the outer 2 terms. X times negative 2 is negative 2x. The inner 2 terms are these 2 that are in the middle. 4 times x is 4x. And then the last is the last in each binomial. So 4 times negative 2, which is negative 8. Now, like I said, the outer and inner, we normally assuming that at this point they have like terms, and you can see in this case it's negative 2x plus 4x. So I'm definitely just going to combine those. So I end up with x squared plus 2x minus 8. Okay, so when you hear FOIL, that's what they're talking about. If you can't remember FOIL, it's really just another way to distribute. It's saying, okay, I'm going to do the first term times the first over here, the first term times the second one, the second term times the first, second times the second. So you're just having to distribute each term all the way through. Now, if it's not a binomial times a binomial, we really are going to distribute. So if I have this, 4a plus 7, and then 9a squared plus 2a minus 7. And once again, I'm just going to distribute. Or you could say distributive property if, you know, that makes you feel better. But I'm going to do the first term times each thing in this second set of parentheses. So 4a times 9a squared. Well, that's going to be 36a cubed. 4a times 2a is going to be 8a squared. And then 4a times negative 7 is negative 28a. So that's, I just distributed the first term in my first set of parentheses to everything in the second set of parentheses. Now I'm doing the exact same thing, except now I'm going to use the second term. So now 7 times 9a squared is going to be plus 63a squared. 7 times 2a is 14a. And then positive 7 times negative 7 is negative 49. So now I have this big, long list of things, and I need to combine any like terms. So this one's an a cubed, and if I look, there aren't any other a cubes. So that's just going to stay 36a cubed. Now this is plus 8a squared plus 63a squared. So those are both like terms. So now I'm just going to add the numbers that are in front because I'm just combining them. So I end up with 71a squared. I have a negative 28a plus 14a. Once again, I'm just adding those numbers. So I end up with negative 14a. And then there's not any that are just numbers by themselves. So I just tag it on to the end. And voila, I'm done. Now, there's one other way that I want to show you, and it works whether you're doing a binomial times a binomial or even a monomial times everything. But in this particular case, we're going to look at a trinomial times a trinomial. So if I have this, x squared plus 5x minus 1 times 5x squared minus 6x plus 1. I could distribute just like I did a second ago, or I can do what is known as the box method. Now, for all of these, whether you're just looking at it as distributing, whether you're looking at it as foiling if you have two binomials, or if you're doing the box method, you get to pick. I don't care which way you're doing it, as long as you end up with the right answer, meaning you've done everything correctly. So what I'm going to do is I'm going to take this first little set of terms, and I am going to, well, basically I'm making, you know, kind of like what you did like as a Punnett square. So I'm going to have x squared plus 5x minus 1. So I'm just doing each term, and remember the terms are split up by plus and minus signs. And I want to make sure I keep a hold of those signs, because if not, I'll end up messing up. And then going across the top is going to be my second polynomial. So I have 5x squared minus 6x plus 1. And my box is a little long, but that's okay. So now I'm just bringing these in, and I'm going to multiply. So this one's x squared times 5x squared, and that's going to give me 5x to the fourth. Now I have positive 5x times 5x squared, 25x cubed. Negative 1 times 5x squared is negative 5x squared. And it doesn't matter if you go across each one and go down, or by columns. I'm just doing columns just because. So x squared times negative 6x is negative 6x cubed. And you realize we're having to use all of the exponent rules. So you need to know what you're doing with these exponents. When you're multiplying, remember the numbers you multiply, but the exponents you add. So 5x times negative 6x is negative 30x squared. Negative 1 times negative 6x is positive 6x. And then everything times positive 1 really is just going to be the exact same thing for each one. Okay, so now that I've filled in all of my boxes, I am going to combine like terms. Now, if these were written in standard form, meaning from highest exponent to lowest exponent each time, then you're looking at the diagonals to combine your like terms. Okay, which is kind of a nice little thing. So if it's not in standard form, you may want to write it that way first. Now, there's nothing to combine with the 5x to the fourth, so I'm just going to write it. Now I have 25x cubed minus 6x cubed, so it's just 19x cubed. Negative 5x squared minus 30x squared plus 1x squared. Don't forget, and if you need to put the 1 in front so you don't forget that, then please do it. So it's going to be minus 34x squared. 6x plus 5x is 11x, and then the negative 1 doesn't have anybody to join up with, so it just hangs on to the end. Remember, you can only combine things that have the same letters raised to the same power. So I can't combine these anymore. That's as good as I can do. So that's what we're doing for the next few days, is we are multiplying polynomials. You know, if you're having any troubles with this at all, this is a very important topic. So please email me so we can set up a time to Zoom and I can help you with some of this stuff. But anyway, the answer to the next question is fox. So I will see y'all next time.